In this video, we're going to talk about areas of polar curves. Recall that when we were finding area underneath the curve, we broke down the area into small little rectangles, and we add the areas of each little rectangles. In polar curve, instead of using rectangles, we need to use little sectors. Now let's review geometry. Sector is part of a circle. An area of a sector is 1 over 2 times r squared times theta, where theta is measure of an angle in radian from the x-axis to the radius, and r is of course the radius of a circle. So when we break it into little sectors, d theta represents the angle of this sector, and of course that is the radius, and the point on a polar curve can be represented by r comma theta. So basically what we're going to do is, to find the area of a polar, we are going to add these areas of these sectors infinite number of times to get the actual area of the polar curve. So in order to find the area of a polar curve, where r equals f of theta, for theta goes from alpha to beta, the integral of 1 over 2 r squared d theta, where integrals from alpha to beta. Of course, instead of r, you could also use f of theta. And let's take a look at some examples. So it says find the area of the region in the plane enclosed by the cardioid r equals 2 quantity 1 plus cosine theta. So in order to do this, let's first graph r equals 2 times the quantity 1 plus cosine theta using our graphing calculator. So put in the 2 quantity 1 plus cosine theta into your calculator and let's graph this. So this is probably in Zoom Standard. Let's go to Zoom and go to Zoom Fit for 0. And let's go to Zoom Square 5. So you get a nice graph. Now let's go to Window. Now to find alpha and beta, we have to kind of check the theta minimum and theta maximum. So notice, we went from 0 to 2 pi to get the full graph. Let's kind of see what happens when we go from 0 to pi. And we only get half of it. So in order to get the full graph, we have to go from 0 to 2 pi. So that means our alpha is 0 and beta will be 2 pi. Now the area of a polar curve is 1 over 2 integral from alpha to beta r squared d theta. So it will be 1 over 2. We found out that we need to go from 0 to 2 pi to get the full curve, and r is 2 times the quantity 1 plus cosine theta, and we need to square that times d theta. So this right here is your setup to find the area of a polar curve. And now we are going to use a graphing calculator to find the answer. Now note that our R1 is 2 quantity 1 plus cosine theta. So go to home screen and press math. You got to find the function integral. So press 9. Now we're going from 0 to 2 pi. And we are going to choose R1. So press alpha, trace, and click number 1 for R1. And you need to square that. And then it's going to be d theta. And press enter. And remember, we have to divide that by 2 because we didn't put 1 over 2 in front of it. So divide by 2. And that is your answer. It's 18.8495. Now on the AP test, setup is very important, and if they let you use a calculator, and most likely on the polar, they will let you use a calculator because it is very difficult to do it without the calculator. Now, next example says find the area inside the smaller loop of the limacon r equal 2 cosine theta plus 1. So what do they mean by area inside the smaller loop? Let's first graph it and see. So put in 2 cosine theta plus 1 into your calculator, and we're going to graph this. So when you graph it, you get something like this. So basically, they just want the area of this portion right here. Now, in order to do that, we only need to get the graph of this smaller loop right here to find alpha and beta. Now notice, at that point right there, the r is equal to 0. So let's set the r equal to 0 and find theta. What are the two thetas? So that r will be equal to 0. That's what we're trying to find. In order to solve that, this will be negative 1 over 2 equals cosine theta. So cosine of what gives you negative 1 over 2? Now remember, cosine is negative in the second and third quadrant. Now, what is the reference angle? Cosine of what is 1 over 2? Well, that's when theta prime, which refers to reference angle, is pi over 3. Because cosine of pi over 3 is 1 over 2. So the reference angle will be pi over 3. But we want this angle right here. That's the angle we're looking for. So that is going to be 2 pi over 3. Because pi minus pi over 3. Now what about this angle over here? What is that angle? That's going to be pi plus pi over 3. Which will be 4 pi over 3. So cosine of 2 pi over 3 will give you negative 1 over 2. And cosine of 4 pi over 3 also gives you negative 1 over 2. And that's when the r will equal to 0. So most likely this is our alpha and that is going to be our beta. Now we are going to confirm this using our graphing calculator. Remember, our goal is to get only this loop right here. So let's go to window. Let's go from 2 pi over 3 to 4 pi over 3. And graph. Yes, we only have the inner loop now. So to find the area inside a smaller loop, all you got to do is 1 over 2, take the integral from 2 pi over 3 to 4 pi over 3, r 2 cosine theta plus 1 square d theta. So this is your setup. And now we are going to use graphing calculator to find the answer. So that is our R1. You go to math, number 9 for function integral. You're going 2 pi over 3 to 4 pi over 3. And then alpha trace to find R1. You have to square that. And data, press enter, and you have to divide by 2. And that's your answer right there, 0.5435. So again, most likely they don't expect you to do this without the calculator. So all you need is a setup and the answer, and make sure you go up to 4 decimal places to be safe.